So what we'll be talking about in this video is very simply how ions will combine to form ionic compounds. So we know that when atoms gain or lose electrons, they form ions, and those ions will then kind of link up with other ions to form ionic compounds. And there's kind of a very predictable way in how this will happen, and this actually is what determines a lot of the substances that we see around us and things like that. Some things that are going to be really important to keep in mind before we start this. The first thing is understanding positive and negative charge. Ions will have, you can have either positive charge or negative charge, and understanding that positive and negative charges cancel each other out. That's not, so you will see ions that have positive 1, positive 2, positive 3 charges, minus 1, minus 2, minus 3. If you have the same amount of positive and negative charge, the net becomes 0. That charge cancels itself out. The other thing that will be important to think about is kind of the number of ions, in particular, the ratio. Right? Both of those things will be extremely important. So really how it's going to combine is we're going to end up combining different ratios of ions that have different charges to get to the point that the charges all cancel out and we get a net of 0. This is something that's really best if we look at it through an example, so let's dive right in. So the first thing we'll look at here is what happens if I have an Na plus ion and a Cl minus ion that are kind of brought together, right? So these two things can combine to form an ionic compound, and how they will do that is like we just discussed a second ago. They will combine in a certain ratio that will give the same amount of positive and negative charge so that all of the charge cancels out and we end up with 0 charge, or a net charge of 0. So if you're looking at these two ions, it's actually going to be pretty straightforward, right? Sodium has a positive 1 charge, right? There's an imaginary 1 when you don't see it. And chlorine, or chloride, has a minus 1 charge. So pretty predictably, when these two things combine, it will only take a ratio of 1 to 1. Now, it might not look like it there, but I've actually just represented that 1 to 1 ratio. And the reason why I've done that is in science, in chemistry in particular, 1s are kind of implied. So if you don't see anything, it's implying a 1. So what that actually means is that there's two numbers in the lower right of each of these symbols for sodium and chloride called subscripts. And the subscripts imply to you the number of those ions that are there. So when you write just simply NaCl, it implies that there's one Na and one Cl. And again, Na ions and Cl ions come together in that 1 to 1 ratio so that you have the same amount of positive and negative charge so that the net charge is 0. I cannot emphasize that enough. The game is get the net charge to be 0. So let's look at a still pretty straightforward but slightly different example. Let's look at an example of Ca2 plus and Cl minus. Right, so now my calcium ion has a 2 positive charge. My chloride ion, that still has a minus 1 charge. I need the ratio of calciums to chlorides that will give me the same amount of positive and negative charge so that I'll have that net charge of 0. So if we think about this, right now, if it was 1 and 1, it wouldn't be even, right? If I had one of these guys and one of these guys, I'd have positive 2 and minus 1. That's not going to get it done. So let's erase my 1s here. They're not really doing anything for me. But what if I had, switch back to my pen, 1 calcium and not 1 but 2 chlorides? Now I would have Ca2 plus, that's 2 positive charge, and 2 Cl minus 1s, which would be a total of 2 negative charge. So that will get it done. This is great information, but this muddle of ions that I have here, this mess, is not a chemical formula, right? This is a chemical formula for our NaCl. So we need to represent this information in a formula. So how we would do that is use our subscript system. Ca is an imaginary 1 here, and then 2 Cl ions. One thing that's good to point out at this point is notice how there's no charge up in the upper right anymore, even though my ions have charge in the upper right. That's because the full unit now, the new ionic compound, has a net charge of 0, like it's supposed to. Doesn't matter that its pieces have charges. The full compound has a net charge of 0. And again, just for good chemistry's sake, we really don't need to write this 1 in, so we can get rid of it. Right, so this is the chemical formula. Back to my pen. This is the chemical formula for CaCl2. This is actually kind of neat. This is icy melt, the stuff you put on your roads and your sidewalks and your driveways in the winter time to help with the ice. Let's look at one more example that's a little trickier. Let's take a look at, let's go the combination of aluminum ion, which is a 3+, and an oxygen ion, which is a 2-. So again, I need a ratio that gives me the same amount of positive and negative charges. It's just not going to be quite as straightforward as it was in the first two. So a second O2-, right, we're not even with 1 and 1, obviously. If we add a second O2-, I'm still not really even, but I'm kind of getting there. But I think you can kind of see where this is going, right? This is going to kind of a least common multiple of 6, right? If I go 2 Al3 pluses, that's a total of +6. If I get, let's put it up here, 3 O2 minuses, that's a total of -6. That'll get it done for me. So again, we'll write this as a formula. I have 2 Als, so Al2, and 3 O2 minuses, so O3. That's your formula for aluminum oxide.